Okay, we are at number 20 now. We're doing a grid. Has an A and an X, and A is where an ant starts. And the ant is apparently going to cooperate for this and move one square with each move. The ant can move diagonally, vertically, or horizontally. So if the ant starts here, it can move up and to the right and end up there. It can move straight up and end up here, up and left, end up there, 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 or there. If it starts at A, after its first move, it can be at any one of those 8 squares that surround A. The 9th square is actually where A was. So if you're looking at it saying 3 by 3, there's 9, there's only 8 because it can't stay where it is. It must move somewhere. So there's only 8 squares that it can go to from there. And the question is, what is the probability? I believe it asks probability, yeah. Probability that after 2 moves, the ant ends up here at X. So what we want to do, remember the 8 squares on each move, there's 8 possibilities. What we want to do is we want to break this up into 2 stages, because 2 steps. It's got to do basically end up in an appropriate square after the first move. I am going to use green for this. Like if, for example, the ant starts by going straight to the left and it goes this way, and it's in this square, it cannot get back to X after one move because, after a second move, because as far, it can only go one move to the right. So if it goes from this column over to this column, then it can't come back to this one in its next move. It could only get back to its original column. So if it goes any to the left, it can't get back to X on the next move. So what we have to do is we have to ask what the probability is that the ant stays in the appropriate position after the first move. And that's what I meant by this. It has to do an appropriate first step. It cannot go to the left. So I'm going to write that down for this. Can't go left. If it goes to the left, it takes itself out of range at the X. It can't go straight to the right either, because if it ends up here after the first move, if it's literally on this square after the first move, the second move is going to put it at one of these 3 above it, one of those 2 beside it, right? So if the ant takes that, or if the ant takes the first step and it arrives if the ant is initially here and there's the X, if the ant goes from here to that square, it has to move off of that square for its second step. So it cannot land here after its first move either. It just doesn't work for it. So after the first step, the ant cannot go to the left. It can't take one of these 3 positions. It cannot go directly on the X, but if it goes straight down to here, or straight up, or diagonally down, or diagonally up, any one of those 4 squares are appropriate. So when you do this appropriate first step and correct second step, what we get from this, the probability of the first step being appropriate, in other words, leaving it on one of these 4 squares, is 4 out of the 8 squares that it might randomly select. So just like all the rest of them, what I've been saying, probabilities are fractions, with the bottom being the total number of ways of doing what you're doing. We're asking what the probability is that the ant takes an appropriate first step, but in actuality, the ant doesn't care. It's just randomly selecting one of the 8 squares, so it's an 8 on the bottom of the fraction. How many of them work for the ant? 4 out of the 8. So the probability that it is in the a correct place to be able to arrive at X after the second step, the probability that its first step leaves it within striking distance is 4 out of 8. That word "and" there means multiply, because it does in counting methods type things. Whenever you see the word "and," make it a time sign. In general, when you're finding out the number of ways or probabilities of doing things, in general, you want to write things in "and" or statements. Really, really simplifies. and or statements, and every time you see the word and, multiply. Every time you see the word or, you're going to be adding. It's just sort of almost a universal rule. With the ors, sometimes you have to subtract stuff back away, but we're not doing that. So if the ant moves to one of these, for every one of these, if it's at this position, I'm going to use a color I haven't used yet, blue. Correct second step. If it is here at this location, then it must go diagonally that direction for its correct second step. That probability, if the ant is already here, if we know it's there, there's a 1 in 8 chance that it takes the correct second step. It's got to go there. No other position, no other direction works that way. 1 in 8. Same thing if it's here. If it's at that position, it must go straight up. That's a 1 in 8 probability. If it's there, straight down, 1 in 8. Or sorry, not straight, diagonally down, 1 in 8. If it's there, straight down. No matter where it is, there's only one square remaining that's the correct square. This is the only correct square, and if it's within striking distance, choosing the correct one out of the 8 possibilities is always going to be a 1 in 8 chance. So you would get that if you reduce it down. 4 out of 8 is 1 over 2. So if we multiply, we get a 1 in 16. And that would be the probability for the ant. As long as the first move leaves it within range, 1 in 8 for that last one. Kind of like rolling a dice. 2 dice, if you're doing 2 dice and you look for a sum. And now my phone's making noise. If you're looking for a sum of 10, your first dice is any one of those numbers. The 1 through 3 doesn't matter, so boom. If you've rolled a 4, you need to roll a 6, and that happens 1 time in 6. If you rolled a 5, your second one has to be a 5. If you rolled a 6, the next one has to be a 4. All those are 1 and 6. So it's real common when you do these type things, when you break it up into several stages and then a last step, that last step, like for us, that last step, it's always a 1 in 8 probability that we take the correct last step. So real common to do that. Dice questions for some, the last step is often a 1 in 6. So anyway, break them up into and or statements. Must do an appropriate first step, one that keeps it within range so it does not go to the left. And then take the correct second step. The correct second step, that's the one that's always going to be a 1 in 8 because there's only one square that's correct. And assuming it can reach it, that's 1 square out of the 8 that it might randomly choose. So that was number 20.